Okay.
Shout it out.
All right, so we're going to look at arithmetic sequences today. And so an arithmetic sequence is one where the pattern is you are adding a fixed number to each term. And so I have a couple of examples down here that we'll look at. So I have 5, 8, 11, 14, 17. So what's the pattern?
3.
Adding 3. So each time it's going plus 3, plus 3, plus 3, plus 3. And so that number that you're adding each time is called the common difference. Common difference. And we do not have to write that every time. They just abbreviate it with a D. So we would say for this one that D equals 3. And it's arithmetic only if you're adding the same number all the way across. If it changes somewhere in the middle, then it is not arithmetic. Okay, so what's the pattern on the second one?
2.
It is 2, but there's a difference. What's different with this one? It's going down 2. So you can think of it as adding negative 2. So they use that adding in the definition. And so it's like adding negative 2, or you can think of it as subtracting 2. So on this one, the common difference is negative 2. And that's how you get the next term, the next term, the next term. Okay, so that's just a quick what arithmetic sequences are. So let's go ahead and look at the next piece. So it says decide if each sequence is an arithmetic sequence. If yes, find the common difference. So you have to look and see what they are. So on this one, it goes plus 4, plus 4, plus 4, plus 4 all the way across. So we can say yes, D equals 4. What about the second one? No, because it goes up 1, up 2, up 3, up 4. It's changing, so that one is not arithmetic. It does have a pattern, and we saw with our equations yesterday some of the ways that you can get that pattern, but it's not arithmetic. What about the next one? Be careful. So it goes up by 4 on all of them except from 1 to 4, it only goes up 3. So it goes up 3, 4, 4, 4. So even though it was almost, it's not quite. What about the last one?
Yes.
Okay, it is. And what is the common difference?
Minus 3.
Minus 3. I should put D equals negative 3. Because it goes minus 3, minus 3, minus 3, minus 3 all the way across. Okay. So what we're going to learn with arithmetic sequences today is how to write the formulas like we were looking at yesterday. So with an arithmetic sequence, there's a general pattern. So the AN equals A1, which is your first term, plus the common difference D, parentheses N minus 1, close parentheses. That's a tiny little box, but we got it there. So the AN is just the notation for the formula, and they call this an explicit formula, which just means that you put in what term you want, and you'll get the answer. You'll know what the term is. It's not the recursive ones where you have to, that have the really funny setup that we had yesterday. It's just the straightforward formula. So A1 is the first term, N is the number of terms, or the number of term that you're looking for, and then D is just that common difference. So it's just defining everything that is in the formula. Okay. So they're going to give us some examples, and it's going to jump around and give you different kinds of information. In our direction, it says find AN, which just means basically that you're going to write the formula. And then it says an A20, which means we're going to find the 20th term. And once you get the formula, you can find whatever terms you want. So they tell us what the first term is, they tell us what the difference is, and so we can go ahead and write the formula. So AN equals A1 plus DN minus 1 is just what we're starting with. And so they give us what the first term is, so AN equals 7. And they tell us the difference is 5, so you put 5 in. And then just to make this easier to use, they will usually go ahead and distribute the 5 out and combine like terms just to clean it up a little bit. So if we do that, we still have the 7 plus, we distribute the 5, you get 5 in minus 5. And then you can put the 7 and the minus 5 together and just get 5 in plus 2. So that would be your formula to find any term that you wanted. And so this is what we call the explicit formula, and n is just whatever term you're looking for. So since they want us to find the 20th term, you're just going to take 5 times 20. I can label that A20. It says my 20th term is 5 times 20 plus 2. So 5 times 20 is 100 plus 2 is 102, and I can easily find the 20th term. The explicit formula is easier to use because it's not like I'm having to add 5, add 5, add 5, add 5. I could keep doing that if I wanted to. It's totally a way that you could do it, but it's easy to lose track. And so the explicit formula is just kind of nice. I can find any term I want once I have this formula set up. Okay, so they're not always just going to give you the information here. This is the first term in the difference. Sometimes they're going to give you the actual sequence, and you have to find stuff. So this time they're going to give us a sequence. Same directions, find AN, which means write the formula, and then find the 25th term this time. And so we can still get information that we need. 48 would be the A1. And then what's my common difference as I'm going ahead in the formula? What are they adding?
5.
5. So we can use that in our formula. So AN equals A1, which is 48, plus 5 times n minus 1. And we can just distribute and clean that up a little bit. So if we distribute out the 5, we get 5n minus 5. And then 48 minus 5 is 43. And so you can do 43 plus 5n, 5n plus 43. Either way works. And so that's your formula. And then to find the 25th term, we would put 5 in. So the 25th term be 43 plus 5 times 25. 5 times 25 is 125 plus 43 is 168. Does that make sense? Okay. We're going to do one more of these before they give us something weird. So here's another sequence, same directions. They want us to find the formula for AN, the explicit formula, and then the 25th term. So the first term's easy. Negative 21 is the first term. What is the difference? What are we adding each time?
8.
I don't think it's 8.
Oh, no.
I think it's a little bigger than that. There's an 8 in it.
Oh, 18.
18. And it's actually a negative 18 since all of this is going in the negative direction. So just be careful. So when we set up our formula, we'll have AN equals the first term, negative 21. And then instead of writing plus negative 18, you can just write minus 18 in minus 1 if you like. Or you can do plus negative 18. Either way works. If we distribute that out, we distribute it like it's negative 18. So I'll have negative 18 and negative 18, negative 1 make plus 18. And then I can combine the negative 21 and the positive 18 together to get negative 3. So negative 3 minus 18n. Or if you like having the n's first, you can totally switch that around and do negative 18n minus 3. But now I have a nice formula, and any term they want me to do, I can just plug in the number. So if they want the 25th term, I just put in 25, and I just, You can put that in your calculator really quick if you want. It comes out negative 453. Or you can sit there and do minus 18, minus 18, minus 18, minus 18 for, yeah. Well, you'd only have to do it, because this would be the second, third, fourth. You don't have to do it 21 times after this. But that still seems like an awful lot.
Yeah.
Okay, so we're going to look at what if they give us some random information. So directions for the next part say we're going to find AN. Remember, that's our formula. And A20, which is the 20th term. And instead of telling us what the sequence is or giving us the first term, they're giving us the 17th term and the difference, which is a little strange. But what we can do is we can work backwards to figure out what the first term is. So we're going to find the first term. So our first objective is find A1. That's what we're going to do first. And so I can put 22 in as my term, and then write A1, I guess since it's negative 4, I'll do minus 4. And instead of n minus 1, I can put in 17 minus 1. On this information that they give us, the 17 is the n, and the 22 is the an. And so you can put that information into the formula, and we can work backwards to figure out what the first term was. Or you could take 22 and add 4 to it a whole bunch and go backwards, which is just a pain. So 17 minus 1 is 16. So this would be A1 minus 4 times 16. And so if you take 4 times 16, that is 64. So 22 equals A1 minus 64. And we can just add 64 to solve for the A1. And that comes out 86 equals A1. So all of this was just to figure out what the first term is so that we can write the formula. So our formula for the generic term now we can do 86 minus 4 times n minus 1. And then we clean it up just a little bit. So 86 minus 4n plus 4, and that's going to end up being 90 minus 4n. So that's our formula that it asks for, the an that's in the directions. And then if I want to find the 20th term, just 90 minus 4 times 20, which would be 90 minus 80, which is 10. So it can be a little bit involved. It's not too bad if they tell you what the difference is. Where it gets really exciting is the next two examples. It's not that bad. I'll show you what to do. So,
Couldn't you just do the difference and divide that by?
yes, Molly gets a gold star for today. So what they did was they gave us two random terms. They want us to find the formula and the 13th term, but they just gave us two terms in the formula. And you could think of this kind of like the slope formula, if you remember that. To find the difference, what you're going to do is you're going to take the terms, so 25 and 10, and we're going to see just how much they grew from here to here, 25 minus 10. And then we're going to see, okay, well, how many terms have we gone through from 15 to 20? And so you subtract 20 minus 15. So it's kind of like the slope formula, y2 minus y1, x2 minus x1. Does that make sense? Mm-hmm. It's kind of the same sort of deal. But this way you can figure out how much it went up each time. So you end up with 15 over 5, which means that the difference is 3. So now we have the difference, and we can do what we did on the last example. We just have two different terms to pick from. We can use whichever one we want. So how about we just use the first one? So we're going to take this information down and find what the first term is. So we'll put in 10 equals A1 plus the difference, which is 3. And then the n is what term that we're on. So we're on the 15th term, so 15 minus 1. So 15 minus 1 is 14. Take that times 3, we get 42. And then you can just subtract negative 32 is the first term. Okay, so we are so close now. We can write the formula. AN equals negative 32 plus 3 times n minus 1. And we'll just clean it up a little bit by distributing. So negative 32 plus 3n minus 3. Negative 32 and minus 3 make negative 35, and then plus 3n. So we have the formula. That's the first answer we actually were looking for. And then if they want the 13th term, A13, we just put in the 13 in the formula. So negative 35 plus 3 times 13. 3 times 13 is 39. If you put the negative 35 with that, you end up with 4. All right, one more, just to make sure we know what we're doing. I figure the more complicated it is, the more examples I should do. It just kind of builds on itself. So on this last one, they want us to find the equation, AN, and the 13th term again. So if we want to set it up to find the difference, let's see if you guys can help me set it up. What would I do? I'll set up the fraction. What goes on the top?
23 negative 33. Yeah.
Okay, so we can do negative 23 minus 37. We can do it that way. Or actually, yeah, that works. And then what would I have to put on the bottom then? 12 minus 27. So we did switch it on the last one. I would have done this minus this, that minus that. As long as you switch both of them, it'll come out okay. And so that comes out to be negative 60 over negative 15, which is 4. So I have the difference, and we can use whatever we want over here. So do you want to use the first one or the second one?
First.
The first one. So we'll put negative 23 equals, and then A1's what we're looking for, plus 4, and then the n minus 1 would be 12 minus 1, since that's the 12th term. So 12 minus 1 is 11. Get everything else copied down here. 4 times 11 is 44. Subtract 44, and we get negative 67 for the first term. So now we can write our formula and get everything done. So AN equals negative 67 plus 4 times n minus 1. Can clean that up a little bit. Negative 67 plus 4n minus 4, which would be negative 71 plus 4n. So that's our formula. And then if they want the 13th term, we just put 13 in. So negative 71 plus 4 times 13. And we end up with negative 19.